What we did today was solving systems by substitution. So we're going to look at the topics we talked about today in class. So first, a system. Oh, I don't want to start off with yellow. Didn't know yellow was pre-chosen for me. So a system is when we have two or more equations. So because we have two or more equations, we'll have two or more letters, depending. Usually we have two letters, one letter per equation. So what we looked at in September when we solved equations was we had one letter, one equation. This is now we're going to have two letters and two equations. That way we can still continue a unique solution. So the steps to solve a system by substitution. Step number one, we need to find a y equals or an x equals equation in our system. If we're not given a y equals or an x equals, we're going to have to make a y equals or x equals equation. That'll make more sense when we go through these steps. I don't anticipate you going, I know exactly what you're talking about with these steps as we go. These steps are just like kind of a checklist as we solve these problems. So step number two, once you have a y equals or an x equals equation, we're going to substitute. This is where this method gets its namesake. We're going to substitute the equation into the other equation. Step number three, we solve. So after we've plugged that equation in, we should be able to solve the equation. Step number four, we've solved it, we've gotten an answer. We're going to substitute the result into the first equation. Sorry, my tablet's not writing as quick here. That was just a botched word there. The first equation. Step number 5, and the final step, we solve again. All right, so let's take a look at what this looks like. With substitution, the best thing to do is write your two equations side by side, not vertically like they are written here. So I'm going to write all these side by side. Step number 1, find a y equals or an x equals equation. For this one, we have two y equals. That doesn't matter. I'm going to choose this one because it's the simplest. Y is equal to -4. Y is -4. What that means is this y in this equation is also -4. I'm able to replace or substitute this y with this value. Now I'm able to solve this equation. I'm going to subtract 10, divide by -2, and I get 5. Oh my gosh. I'm sorry. I knew there was something weird about that. So we subtracted the -10. That gives us -14 equals -2x. This is why you always show your work and put your steps in there, because you could just kind of lose track. We divide both sides by -2, and we get 7 is equal to x. For our systems problems, we have an answer for x, we have an answer for y. We're always going to write them in an ordered pair. So x is 7, y is -4, and there's our answer. What we're doing is we're finding where these two lines intersect without graphing a single line. So for instance, if I had graphed these two lines, y equals -4, it's a perfectly vertical line right there, -2x plus 10, so it starts way up there, and then it cuts where these two lines cross is that coordinate point right there. All right, skip that one. Let's go to this one. It's almost an x equals. So the first thing I'm going to do is I'm going to write it side by side. And I need it to be an x equals. Well, it's almost an x equals. The only thing I need to do is divide everything by a -1. That way it becomes a positive x, positive y, and a positive 1 in this case. X equals, so x is equal to all of this. So I'm going to replace the x in this problem with everything I have circled. When this substitution takes place, the only thing that changes is the x. So the 5 is still right there. This is when I would have written the x. So instead, I'm going to write my substituted value, y plus 1. I still have the -7y, and I still have the -3. I distribute the 5 to the parentheses to get rid of them. The rest of the problem stays as is. I'm going to combine my like terms. I'm going to subtract 5 from both sides. I then divide by -2, and y equals 4. That is half of our answer. So right now our coordinate point, we have 4 right there. I still need to find x, so we're going to plug that 4 in right here. So x is 5. With substitution, it is possible that neither of the equations says x equals or y equals. This is like the last problem on your homework. In that case, we have to make it say x equals or y equals. Which one we choose is really up to us. So if I look, this 5x doesn't look like it's close to being by itself. This 3y, same thing. This 7x, not really. But this y is almost by itself. If I was able just to get rid of this, I'd have a y equals. So we're going to do just that. To get rid of this 7x, this -7x, I'm going to add 7x to both sides. I like having the variable go first, so it's 7x minus 22. It is exactly the same as 22 minus 7x. These are exactly the same equations. Notice that the 7x is, oh, no, they're not like this. Of course they're not. Now I got it. 7x's are both positive. The -22's are both negative. This is why I don't like switching around. That's why I keep it one way for myself. Now that I have a y equals, I'm going to take this y equals, plug it in for y in this equation, not x, in for y. So I get 5x minus 3, 7x minus 22 equal to 2. I distribute that -3, so I get 5x minus 21x plus 66 is equal to 2. Combine my like terms, so I get -16x plus 66 equals 2. Subtract 66. -16x equals -64. divide by negative 16, and x is 4. Again, that's just half of our answer. We're going to take that 4, we're going to plug it in up here. Y equals 28 minus 22, so y is 6. You can always check your answer by taking the coordinate point and plugging it back in to both of your equations. So what if x is 4 and y is 6? You better get an equal equation. So this is 20 minus 18. Do you get 2? And then 4 and 6. So you get negative 28 plus 6 equals negative 22. So if you do that, you get the same answers. That's one way you can check if I did not provide the answer for you.